Hello everybody, thank you for having me in this year's edition of XtremeJ. This time we're going to talk about design patterns in an IoC-based framework. These examples are going to be with Spring, but you can abstract it away and think about Quarkus or whatever you want. I'm just trying to be more close to people, and since Spring is still the most common framework in the Java space, the examples are going to be using Spring, but you can reimagine them yourself in any other framework that is IoC based from its core. So the idea of this talk is to have implementing some of the common design patterns to make our code base more extensible. Or the whole idea is to have at least a little bit more code quality than if we do not apply any code quality principles at all and just follow any three-tier architecture. But before diving into that, let me tell you some words. Who am I? My name is Yonkov, and I'm the CEO of the software consulting company called Codexio for the past almost a decade. You can say, okay, is this some business guy talking about something technological? No, my experience is purely technological. For the past 15 years, I'm quite involved into the Java community in Bulgaria, and I'm a Java developer myself, or a Java archaeologist. Because what I'm doing usually is diving deeply into these old projects, trying to understand what's happening, trying to fix some things, dig deeply in some systems that exist long before I ever started my career. So I can say that I'm trying to find some leaks there and trying to improve them. Hence, this title of the design patterns is something that probably is also dictated from some of the projects that I've been involved in, where we've implemented lots of improvements using the IoC-based frameworks and the design patterns over them. But enough for me. Let me present you what is the agenda for today. And today we're going to focus on 4 pillars. One of them is to refactor some code. We will present a code base that violates some of the code quality principles, so we need to refactor it. But before that, we need to evaluate some patterns that can be used here and there, and then, of course, to implement them. But if you're going to implement these patterns in a raw variant, like in a project that you start in your main method, that can be quite difficult, and this is where some people just say, okay, I need to write lots of boilerplate in order to implement my patterns in a good way. But that's not the case, because we will see the benefits of an inversion of control container, which Spring and Quarkus and other frameworks are implementing behind the scenes. So let's go to the refactoring of some code base. I'm going to present you a code base where some of the things violate some of the principles. We're going to focus on these violations, not on the other boilerplate, and of course trying to go there and focus on these things, try to improve them, implement patterns that will make the code more extensible. So we are presented a flight ticket reservation system. In our database, we are storing some flights, where they are depart from, where they arrive to, with some pricing lists. This data model is not the one that we're going to refactor. This is given. Maybe it can be made better than it is now, but let's not focus on that and use this as a given, because we are going to use the same data model when we refactor the database. So we have a flight, which have an airport and the time where it departs from. It has also an airport and a time where it arrives to. And it has some list or set of pricings, because maybe you're buying a business class, maybe you're buying with some other conditions. So all these conditions are stored in another table that says, okay, for this price type, the amount is this. And the price type can be any enumeration or a joint table, like any row in the price type table says it's economy, business, or something else. Okay, so what we are going to do next, or what is already there next, because this should be our imaginary old code base that we need to refactor. Well, we have this request object that says, okay, give me the price for a flight ID 6 with this filtration pricing type business, for instance, for 6 people. And now we need to give this quote to the user based on the quote request and the flight ID. And in a very general case, you may see people implement something like this. Okay, they find the flight by ID, that's fine. Then they find the price info when they filter the price object that we've seen before. Compare it, let's say, against the request object and find the particular price info object. Now, since they have the price amount of this price info object, they can, of course, return it. But it depends on some cases. For instance, if the price type is business, maybe we need to see some other options, like, okay, for business price amount is 1,000 euro or 1,000 USD, that's fine, but also it depends on other variables, which can be the duration of the flight. If the duration of the flight is more than 10 hours, probably the price can be discounted by 20%, or if it's between 5 and 10 hours, it can be only 10% discount. Or let's say if you're booking for more than 3 persons, also you get a discount because of that. So these rules, usually you see people implement them this way, with a bunch of if-else if statements, or ifs that are not tied to each other. So let's say the duration and the persons, they can be stacked. So you can receive 20% discount because of the duration, and then you can receive another 5% discount because of the people are more than 3. The same can apply for the first class instead of the business class, where we have another rules. If it is between the small hours, between 1 or 4 a.m., then maybe you can give people a discount because of the inconvenience that they need to go on the airport in a very inconvenient time. Or let's say it's again, if it's between if it's arriving between 2 and 6 a.m., again you can give them some kind of a discount of 5%. And for the economy class, you don't care about people when they depart or arrive. You may give them some discount if they buy for a large amount of people, like 10 people or 5 people. And on the top of all of that, probably you may have another rules. You'd say, okay, let's see how many time there is between now and the departing time. And if there are 6 months, for instance, well, that's fine, that's very early booking. Maybe we can give these people some kind of a discount too. And then, after all these things being checked, then you return your flight quote to your end user, and they can purchase the ticket or not purchase it if they want. So, what is the problem with all of that code base? Especially in my career, this is a very common code base that you may see in most of the projects. Some nested conditions where they check data from the request or different sources and the data inside our database or other data stores. Make all the conditionals and then return a result. This is a very common scenario, not only in flight ticket quoting system, but any system that I've been involved was having some kind of these conditionals. So probably it's not something that you haven't seen, probably you deal with this every day, and we need to convince ourselves if there is a problem here. And according to me, there is a problem. And problems are several. It's not only one problem. It breaks the single responsibility principle. Now this method that's quoting your user, it has more than one reason to change. The single responsibility principle says not that only one object needs to do one thing, but one object or one method need to have only one reason to change. And this is a problem here. This method may change because of the business class, because of the economy class, because of the duration of hours, because of the implementation of another type of ticketing or implementation of another rule that we need to add to our discounting system, or probably it may change depending on how you query your database. So it has lots of reasons to change. This is one of the things that may be problematic. Here it could be an easy fix by splitting this into different objects and methods, but it's still not the core of the problem. I can say more of the core hides into the fact that it breaks the single responsibility, the open close principle. This means that every time we have a new rule, we need new changes. And the open close principle says, okay, your code base should be open for extension. New rules should be able to come. But your system or your module should be close to modifications. So each time a new rule comes, maybe you need to add new classes, but you have not to change the existing ones because they have already the general business logic there. And this is the principle that I'm trying to follow by heart in the past decade. And this is the principle that we are going to fight now and implement some design patterns and principles that are going to conform this. But also there are other problems here. It also breaks another solid principle called the dependency inversion principle. It has very concrete low-level logic. And this concrete low-level logic should be encapsulated into other more low-level objects, and they to be used there instead of direct logic being here in place. So all of these three problems we are going to fight now. But especially the middle one, the open close principle. If we actually solve the problem with the open close principle, we are actually going to solve the other problems by itself. But let's see what's going on here. What possible design patterns we may need in this example. So if you see the three types that we are having on the price info, which are called business, first, and economy, only one of them can exist. So if only one of them can exist, we need to choose which one and apply it. And choosing one type of thing to happen and apply it, in other words, it's choosing one strategy to apply. So yep. This could be this so-called strategy pattern where we have a business strategy, first class strategy, economy class strategy. But you can see also that there are not only things that happen only one of them, so only one strategy being chosen, but there are things that are happening chained one after the other. For instance, we have the departing and the arriving time of the first class, which both can coexist. You can receive 10% discount because your flight departs in 2 a.m. But again, you can receive another 5% because the same flight arrives at 3 a.m. and on the other destination, being it only 1 hour flight or 25 hours. flight or whatever it is. So these things can coexist. So there is another pattern that's very similar to the strategy pattern, but allows you to change these rules, and it's called chain of responsibility. This same thing, of course, applies for all the things that are not else ifs. You can see the two squares on the left, which tell you that these else ifs with the other if they can coexist. So probably they can be part of this chain of responsibility. There is another pattern maybe we need to evaluate. The same thing can happen not only with the chain of responsibility, but also with the so-called decorator pattern. Yeah, lots of patterns that we need to reevaluate. At some point, we are going to something like this, the office. This is the office explanation. So you say, okay, Ivan, you crazy? Lots of patterns, lots of if else's. What are we going to do here? Are we going to have a decorator specification? Are we going to have a chain of responsibility? Are we using only strategy pattern? What is it happening here? And of course, this pretty much depends on how you evaluate the whole code base, and how you speak with your colleagues, and what of these design patterns seems more natural to your team. But at that session, we're going mostly to focus on the strategy pattern, because in a sense, it will be going to be implemented the same way like any of the others. Of course, inside the strategy pattern, we are going to see the chain of responsibility, and then we are going to see something more, that we can strip it down to one pattern, and it can be only the chain of responsibility pattern, but with some other tweaks and tricks there that make some things to execute with coexistence, and the others to be like grouped, and only one per group to exist. So it requires a person to evaluate the code base and do what? Find the most common denominator, let's call it. And when you find it, then you can see that maybe one or two tools can be enough, instead of spreading around of 10 design patterns and stuff, and make it like a student project instead of some real enterprise stuff. So let's continue and see what we can actually do. All these cases, business first and economy class, we can extract them to something that we may call price strategy, which accepts the flight, the quotation, the request from the user, and the amount so far that we have calculated. It can be the amount from the database or amount that is already recalculated because of another application. Do something like check the duration, check the number of passengers, and return the amount. For the economy flight strategy, it's the same. Again, you receive the same input, the flight, the quote, and the amount. You make some checks, you do some calculations, you return the new amount. And what do you do after that? Well, you say, okay, I need to get my strategy from a map of strategies. Then when I get the relevant one, it can be the business or the economy or the first class, depending what object we choose from that map, and then calculate the price. And okay, maybe we can have more of that. Some rule engine of duration rules that also can be used inside the strategies to apply duration rules, to apply passenger rules, to apply any other rules that we may need. So how would, let's say, the business flight strategy class would look like? It can have several rules, and any of these rules can be used to be applied, and of course the final price will be returned by that. Okay, so you say fine, we have a list of rules, we have a possible map of strategies also, but where are these things coming from? How do we have a map of our strategies? How do we have a list of our calculation rules? These are essential problems that you find when you are trying to implement these patterns, and in a bare, raw, no framework project, you need to write a lot of boilerplate to have all your classes or your strategies put in the right maps. You need to do then other conditionals there. You say, okay, if I write the conditionals there, if I put manually my strategies here, I still break the open close principle, so screw it, I'm not gonna do it. But using any framework like Spring makes things very, very easy. So let's say this business flight strategy is annotated with component. So what is going to happen here? This business flight strategy class will be instantiated by Spring Framework, and after that it's gonna be put into its inversion of control container. And if we want to inject it, we can inject it directly. We can say, okay, private final business flight strategy, but we can say, okay, private final map of string and price strategy, and then all price strategy objects will be hydrated into that map as values. The interesting part is what are going to be our keys, the string in the map. Well, it's going to be the component name. This business that is put inside the component are going to be the key inside the map. So you can easily say, okay, from my request I receive business as uppercase, then I can easily find it in the map. I don't need to do any if else or any other conditional to find the particular strategy that I need. Actually, I just take it by name. And this is very, very powerful tool inside the inversion of control containers, that they can give you all your beans grouped by some abstraction, like the interface or the abstract class they extend or implement, and retrieve it to you in a map or any other iterable structure like list or set. And let's get back to what we have here. So we have a lot of grouped if else's, like for the duration, for the persons, for the arriving time, for the difference between the current time and the departing time, and all of these things can be reduced down to something called a rule, and each rule can be a part of a group, and it can have its own order, so the groups can be executed in order. And then not only the rules can have order inside the group, but the whole groups can have order too. So you can have a group of business strategy rules, then you can have another group of let's say this one. So the early reservation duration here can be one group itself. The rules for the business strategy can be another group. These groups can coexist. The things inside the group can also be ordered and also coexist inside it. And then you execute each group in sequence. And only one rule per group. So we need to see that in action, otherwise it sounds like very abstract thing. But let's see it here. So let's say the duration is group 1. So we have 3 rules there: group 1, rule 1, group 1, rule 2, group 1, rule 3. Then you have the persons, and it's already group 2. Then you have the first class, and inside the first class you have one group that is the departing time. It's group 3, rule 1. Since you have another group, it's not an else if, but a completely independent if. it's another group, group 4, rule 1. Then you jump to the economy class. There is one group with 2 rules, so it's one group only. The next group is group 5, rule 1, and again in the same group, 5, rule 2. Then we move to the difference between the current time and the departing time. And it is again another group. It's one whole group with 3 rules. Group 6, rule 1, rule 2, and rule 3. So we need only these kind of rules, and they can be our strategies or chain of responsibility classes, and only these rules to be executed in sequence, one rule per group. So let's say we have a discount strategy interface. It has the grouping priority, the priority inside the group, the inner priority between all the rules inside the group as well. We have a method that tells us whether this specific strategy, the duration business class strategy for instance, supports the request, and if it's not duration, if it's not business class, probably it doesn't support it. And then to apply the discount. So let's say every rule that is bound to the business discount strategy will inherit the class, the abstract class business discount strategy. It says, okay, rules here that are part of this group can only be applied if the pricing type is business. They cannot be applied otherwise. And then you have a specific class, or again a grouping class, which is the discount, the duration discount. So it's again part of the business discount strategy. This more concrete abstract class, still abstract but more concrete, is part of the business discount strategy. So the things that will happen for the duration, whether the duration is 10 hours, 15 hours, or 2 hours, or whatever it is, these things are going only to be applied if the parent supports method succeeds, which says, okay, my supports method says I need to have pricing type business. So now we need to execute them in order, but this order should have some buffer, because again, if we go back to open close principle, we need to have a way to add new things without scrambling the whole code base. And how we can do it? Well, if we are too tight here, we may not be able to put something in between if something happens. So we need to have some buffer, like tens or hundreds. But let's see one more concrete one, which is the 10 hours duration. 10 hours discount strategy, which is kind of a duration discount strategy, which is kind of a business class discount strategy. It says, okay, my supports method needs to have needs to execute my parent supports method, which is the business class, and then if this succeeds, if we are in a business pricing type, then we will go to the duration between the departing and the arrival time, which should be more than 10. And only if this succeeds, we will apply the discount, which is almost 20%. Again, for persons, it's another group, so we have a grouping priority of 20, the next group. And the same thing here, the person's discount strategy, which is again business discount strategy. Again, calls its super method, which says, okay, I need to proceed to the persons only if I am a business type, and then the persons should be more than 3. This more than 3 inside the group has the first priority, which is 10, and applies roughly a 5% discount. So how do we execute all of that? Well, we need to have all the discount strategies. So we receive we receive a list of discount strategies, and then we need to make it a matrix of discount strategies. How do we do that? Well, this means that, first of all, what does this mean? This means that we need to have them by groups, and then the particular rules. So the group 0 with rule 1, again the group 0 with rule 2. Okay, I made it very I made it very colorful here, but that doesn't matter. So how do we do that, grouping it? Well, we need first to sort the things by the grouping priority. When we sort the things by the grouping priority, we need to go inside, group this one, and then sort the individual rows by the inner priority. And when we have that, we will receive something that looks like when we debug what we have inside this thing, we will receive something like this one. We have 5 groups or 6 groups, as you can see, from 0 to 5. These were the 6 groups from the beginning that we saw them, group 1, group 2 to group 6. And each of these groups we have individual rows already sorted. So you can see that the first group here has 3 rows. The 10 hours, the 5 hours, the 2 hours. You can see again, the fourth group have more than 10 people and then more than 5 people. Again, for the duration, 6 months early reservation or 3 months early or 1 month early reservation. So each of these groups is there, already sorted. They should be executed by this order. So what do we need to do now? Go through all the groups. Each of the groups we need to execute one rule. This one or this one or this one. For instance, when we go to this group here, we cannot execute 6 and 3 months. We need to execute only one of them. But each of the groups should be tested and probably executed most of one rule. How do we do that? Well, we need to go to all the grouping strategies. And what we need to do there is to find only the first one that is supported by each group and apply its discount. Yeah, I know, with this reducing thing here, seems very ugly, the functional approach. I personally prefer it more, but if you want to see the illustration more convenient, it's the same as if it was that one. Let's start with one price. Let's see that. Let's say that this flight would cost us 1,000 euro. Then we go from each group, and then we go for each strategy per group. If one strategy per group supports the request, then the amount is sent to the apply discount. The discount happens, let's say 20%. This thing here goes to, let's say, 800, and again the loop goes to the next strategy because it breaks here. The next strategy maybe doesn't have any rules to be supported, so it was skipped entirely, then to the next strategy, then to the next strategy, then one of the other strategies have one rule that is supported. It says, okay, 10% discount, then we go to 720, sorry, and again, this is reducing the amount at some point, returning, let's say 720 by starting of 1,000. So let's put this all together. If we have the price amount that's there by this type, so for the business class we have 1,000. Then what we do then, we say okay, but this price will be sent to the discount executor. The discount executor will do the things from here. He receives the pricing. We do this. We then return a double, which is here, and this double will be this double here. And then what we need to do is just to return it. Okay, how does this work inside the whole class, the service or whatever it's doing? Let's say it's a flight service. Okay, so our flight service is having a flight repository and the discount strategy executor. And this method that we saw before the discount strategy executor will going to be directly hydrated by the Spring inversion of control framework, and what will happen after that is that the discount strategy executor will receive the list of all rules, and all the rules then will be grouped in the constructor as we saw it before that, which was this one. We're going to have this list or the matrix of discount strategies, and what's happening next is just having this piece of code that's going to be the same. So what we achieved, because maybe now we are more confused than in the beginning. What we achieved? We have achieved a code base, this class flight service, staying there completely unchanged forever and ever. You never need to change anything there. If you need a new rule, you just create a new rule, class new rule. You say, okay, it's component. You implement the discount strategy. You say, okay, my grouping priority is this one. It's, let's say, 35. My inner priority is 10. And then you have a new rule. And this new rule will be picked if you restart the service. This can be compacted in a jar. This flight service may never be needed to be recompiled ever again. You may only add new jars in your application class path, for instance, with the new classes. So what you achieved is a completely untouchable code base that applies the open close principle. It is open for extension, but this one is closed for modification. You never modify this piece. You only add new classes. So let's see what you need to remember, because there are things in Spring that make your life easier for this thing, and this is that you can inject beans as lists, sets, or maps from their parent type, or any of their parent chain. It can be an interface on the parent chain, on the upper parent chain. It can be their direct parent, depending what you want, how many of them we want to receive. You can say, okay, private final list of something, and you receive all the beans. In the map, the key is the bean name. Whatever you say in the component, it means that you have a component with some name, a service with some name, or if it's a factory bean, you can have even more than one name if you want. If you want to do a decorator pattern, you can just create a new class that wraps the other one and use primary, but it's something that I wouldn't recommend because it's a one shot, then your hands are again tied. If some beans are not necessary for you, you can create them conditionally. There are some strategies to do it. Of course, you can use an if statement. You can say, okay, if something is present in my application YAML, I will return bean1, otherwise I will return bean2 or nothing, for instance. I can use conditional on, like conditional on missing bean, conditional on configuration property, and so on and so forth. And most importantly, according to me, of course, it is don't ever violate the open close principle. It will save your life. Thank you very much. My name is Ivan Yonkov. You can find me in LinkedIn if you want, or you can follow our company in the social media by this tag name here. Thank you once again, and I hope we can speak you later. Bye.